Okay, I'm going to first talk about homework assignment number 3. Um, so the server that will count your score, for example, this is the example, the post from the GitHub, post A002, I believe. Let me actually take a look what I am doing here. This is the post for, wait a minute, I have to expand it. No, it's not here. It was in one of the assignments. Let me actually pull out the assignment very quickly. Let's be under document, assignment, homework 3. So homework 3, I gave you one. This is the post. Oh, I'm using ECF36B. So this one is the post that I gave you the link in the assignment. So this is the post over here with this link in the homework assignment. So I already downloaded to my computer. So when I do the update, and of course I'm running the server is running here. And so when I run it, you can see that, let me actually give you two number. Okay, so the total number of exception is 53. There are 53 exception. And there is, so the unique exception is 19. So you have to get exception. The unique exception means that if you have, as I showed you last time, if you have a 2, that's actually the same. Let me actually find you an example. Let me use one of this as an example. That means you're causing the same kind of exception, which I hope you will find different places to trigger a different kind of exception. So for example, this is one exception. And this 2 exception I highlight here, they're actually identical. You look at this, there are 5 attributes about each of the exception. You can neglect how and index. In this homework assignment, they will all be the same. You only need to look at what, where, and which. What means what's the type of exception you generate. Where is which class, which object-oriented class that's actually causing the exception. Which is which attribute within the class that's actually causing the exception. For example, this exception saying that, well, there is a key missing, the key value pair, the key missing, and the missing part is under class person, and the attribute is name. So if I come over here to take a look, this must be person. So under the person, you can see that there is an attribute called name, there is an attribute called home. So you need to have, when you try to do JSON to object, that means you want to convert a JSON version of the same object to C++, but you don't have anything to do with name in that person, then of course it will complain an exception. So if you take a look at the original JSON, let me actually pull it out. So this is the JSON. Let's take a look at some of the person. Let's search for person, by the way. Search for person. I'm actually just guessing. It must be from, because you see that the from is avatar name. It doesn't have a name. It doesn't have a home. So from is a person, but this JSON is actually offering you something different. Therefore, you're actually causing the exception because this was an older version of a JSON, which doesn't have a name, but instead of not having name, they're using avatar name. That's why it's causing the exception. Missing means that it need to be there in order for me to convert the JSON to C++. Because you missed the name, and this will cause an exception. However, let's get back to here that these two are identical because this one, both of them, the type of exception is JSON value key missing, or you can call it key value missing. Essentially, they're missed that, and then both of them is under class person, and both of them is under name. So these two will be considered as duplicate. They're not unique. So the new version of the server, it will count only the unique exception that your posts generate for this. So even though the 53, I count only 19 of them are unique. And then you will not be able to get the full score if you do that. Okay, this is another, let me give you another example. It must have lots of similar example. Or host URL. Oh, okay, this one is the same. You take a look at this. This is another one. This is it's also value key missing is JSON object class core. And the attribute is object ID. And then you can take a look at here is the same thing. JSON value key missing and the JSON to object class core and then object ID. So that's why it's actually having this issue. I can tell you what I did for this one. Okay, so just show you how I can do this kind of check. Server. So just show you that what I did is the code before this line, I'm actually generate this called unique exception count. And after this, I will check. The value is called EU index. I actually have this called exception, unique exception. I don't know why I call it EU. Probably not necessarily a good name. But if your unique exception is greater than 20, then your homework 3 grade will be 20. I mean, that's the total score you're going to get. Okay. So over here, the piece of code, what I just did is that if you have a greater than 0 exception, what I'm going to do is I'm going to check if you have, I'm actually recording under this what I call EU array, is checking if this is all three of them are the same, means where is equal to where, what is equal to what, which equal to which. Then I say, okay, then this is a duplicate. So if found is a 0 means it's not duplicate after I went through the whole array, then I will actually increase the EU index and save this new unique over there. Okay. And you can neglect all the printf. I was panicking earlier this morning. I said, why this is causing problem? And then that's why I just print a lot of stuff just for me to check. Okay. So that's the way you should do. And the other way is very important. You need to add in this JSON, you need to add the name of your name for your participation, and such that just the way you do your participation, such that your score will be recorded. Okay. Okay. The other thing I want to show you is this. So I don't want to add one more exception, but I want to reduce the exception. Now the exception is 19, right? So let me actually pick some of them. It's a 53. So let me pick one thing. So I try to get rid of the name exception. So what do I do is my best guess is that in this version, I'm using avatar name. So I'm going to change that. Oh, I already did that? Whoa, that's quick. Did I kill my server? I guess I did. Still 19. Let me actually check what I did, what I didn't do, or what I did. Did I miss any one of those? Oh, I still have a name over here. So you see, I already reduced from 53 to 50, but I'm still having two from or whatever is actually still missing two name. I'm going to get rid of the last two. Okay, I'm just going to manually search. This from I changed to name. This I changed to name. I changed to name. Change this to name. I must have some place which is a person, but I didn't change to name or I didn't have the name at all. That's very strange. Where did I get that name? Okay, this is not ideal because I I have a JSON, but I kind of know the type, but I couldn't find exactly which one generate the exception. So I'm going to use another example. Maybe it's easier. Let me actually use this. I know the number reduced, but I don't know which one is still missing. But let me use another example, which I know the is easier. Okay, so you can see that I have a class, which is a class post. It's supposed to have a attribute called created, but I don't have that. So the posts need to have created and need to have is published. So let's actually take a look. It's hard for me to believe I don't have those. Yeah, it is here. It is published. I know what happened. Hold on 1 second. You can see that here is says is published, is not underscore, but over here is underscore. So over here, I bet if I change this way, I can actually get it down by 1. See, it reduced to 18. And that one is taken care of. Okay, that's always the tricky part that we try to convert this to owner, object ID, and sometimes things like that. Okay, So this is going to help you to determine the unique. I better upload the newest version to the GitHub now, so you guys can play around with this. It must be under here. Okay, perfect. So I'm going to add a code to this upload file. And I'm going to go to my download directory. And I'm going to go for the EE1520 server. Where's the server? Oh, here. This one is what I did. So with the server, and just remember, you always include your name, okay? Such that your program should be, so now you can use this one to check whether you have enough. Okay, so you can see it's not that hard to. I already gave you the example with 19 unique exception. To add one more shouldn't be too hard. Okay, shouldn't be too hard. I'm not going to give you the hint. It's if you understand what's going on, it will take you about 10 minutes to change the JSON and get it to work. But to test it, you need to download the new version, which has the capability with checking the unique. Okay. And the other thing I want to let me check with this is the client. I want to make sure you guys are using the right URL. So where is the update? Where's the update? Using update. Okay, I'm using update to do this. And the update, where's the wait a minute, where's my here. Okay, so I'm using this one. This is for local 8301 localhost. But when you submit it using this one, 156, when you submit it using this one, okay? This is going to, if you run in your own server, you can get more than 20, and it gives you homework 3 grade 20. Then when my server is turned on, you actually just change that line of code, and then you send it to me, and I will be here so I can check whether I receive your entry correctly. Okay, we only have not too many students, so I can actually easily count for all of this. Okay. All right. So I want to discuss another topic, but I still have trouble to log into my NVIDIA machine. So I'm going to using the GitHub to kind of talk about the GPU programming. Okay, so I have a directory. This is a new directory under sfelix CUDA. And it has a bunch of program, which is I'm going to add more. I actually tested on my server, so I upload the code over here. Okay, so let me actually tell you the simplest program to start with this lecture. By the way, because we don't have any homework assignment to this, I'm going to add more lecture to the class directory, and you can actually, if you have time, you're interested, you can follow my lecture about the whole sequence about both CUDA and ROCm, which is AMD. But the trouble is I need to have a CUDA machine in front of me in order to run this program to you. But I want to show you, at least gave you some very simple flavor about what the program really is. So when we talk about a GPU programming, that we have this program, hello.cu, this is probably the shortest program that involve a GPU. And this program, so in terms of the GPU programming, the basic idea is the there is a difference between the program that you will be the part of the program you want to run on CPU versus the part of the program you want to run on GPU. Usually, when you write a program such as a C or C++ or Python, you don't need to worry about whether this program is going to be running on the CPU of your system or it's running on the GPU of your system. To make things a little bit more complicated, as a programmer, you shouldn't even worry about whether this is GPU on your own computer or this is a GPU running on some other server that connected on the internet. This is called a transparency in computation, meaning that I just want to perform a computation. I don't want to worry that where exactly is being executed. Okay, so essentially CUDA programming at the lowest level. If you use like things like a PyTorch, most likely you're using CUDA at the lower level, but as a programmer for Python or PyTorch, you don't need to worry about that as well. Okay. So therefore, this is really unique to C or C++ programmer that we not only need to know, are we executing this on a GPU processor or we're using the memory that's actually associated with the GPU or associated with the CPU. So essentially, that's why at the beginning of the class, I started to talk about memory cells and the memory model for Unix operating system. It's really, you will see a lot of advanced lower level computing. The programmer need to be aware of the memory issue. So I'm going to show you this for today, the first lecture. I'm going to show you some very simple example about that difference. So if you have, this is called, in CUDA's terminology, is called kernel. It's called kernel. And essentially, if you have a piece of code started with underscore, underscore, global, underscore, underscore, if you have this leading keyword, that means this part of the program is going to be executed on a GPU. So this means that this from line number 5 to line number 7 is going to be running on the GPU. So there is another example. Let me show you. Come on. I mean, for example, this program, I call it add thread. So in the add thread, I have another program called adding together. You can see that I also have a global underscore, underscore, global, underscore, underscore. And this one is also represent that this part of the program is going to be run on a GPU. All right. And the other thing I should clarify that in order for you to compile this program, you cannot use G++. You have to use a compiler called NVCC, which is NVIDIA C compiler, which is compatible with various versions of G++. Okay, and of course you have to write the correct style, and it will be compiled. So the only difference between G++ and the NVCC is NVCC knows how to understand keywords such as global, and you can use those to instruct the program and the runtime support to distribute the code to a GPU. I mean, if you think about the CUDA infrastructure, essentially what they're doing is, if I want to execute this program on a GPU, that means I have to do two things. First, I have to load this part of code to a GPU. Second, I have to copy the memory from the CPU memory to GPU memory. Typically, in this part sometimes is tricky. The shared memory model in CUDA is very important, allow multiple kernel to share or multiple thread. Remember, we talked about thread about 2 weeks ago or 1 week ago, I forgot. And they can share the memory. If you remember, we actually, this quarter, we talk about two different concepts in terms of this kind of concurrent programming. One is called remote procedure call. So remote procedure call is a client running on one computer and server running on the other computer. But typically under remote procedure call is two separate programs. Therefore, these two programs, they're not sharing the memory. But then we talk about threads. Within threads, then you have the same program has multiple thread, multiple concurrent thread. And then among those threads, because you're under the same program, you're under the same, what we call process memory space. They share the same memory process space. So therefore, when you have a thread, you can share memory. And the third thing is now we're talking about CPU and the GPU. By default, GPU and CPU, they're not sharing the memory, which means that if you have an activity related to memory that's running on CPU, you cannot access to the memory that's being allocated to the GPU. The reason doing this is hardware. It's nothing to do with software, it's a hardware. Because the hardware architecture, the NVIDIA processor or AMD processor or Intel processor, they kind of separate the memory closer to the core and such that they can achieve higher performance. And yet, because of the higher performance, so they cannot allow the shared memory. Okay, so this is, let me actually pull out a slide. So I want to tell you this is the trade-off. I should actually use the PowerPoint slide to explain this a little bit because I feel this is something which is a electrical engineering student should know at this level. Let me pull it out just a little bit. So this is relationship, traditionally relationship between CPU and the memory. And then in order for CPU to access the memory, you have to use something we call bus. And the typical today's bus is called PCIe bus. So within this bus, you can access to either a memory or a device which has its own memory. You're using that bus to do that. But whenever you use the bus, it is going to be causing some performance. You're going to sacrifice some performance in order for you to access to that. Therefore, if you think about that's why you have a concept called cache memory. So cache memory is being designed to be both fast and also closer to the CPU. They're supposed to be really close to the CPU, so they don't have to use things like a PCI bus. They can directly access to the memory. Okay, so you can see that is the memory model is coming in not free. The closer the memory to the CPU or GPU, the faster the access delay. It's faster for you to get to the data. When you have a separate between CPU and memory over the bus or even over the internet, which means that it's more general. You can share more memory, but it's going to be slower. Whenever you want to share, it's going to be slower. So therefore, from the computer architecture perspective, what we want to do is we want to do this trade-off. should I design the memory such that I put a lot of memory, but those memory are really close to the GPU, for example, and such that it's going to be fast for GPU to access, but you need to copy it once from your CPU or operating system to that memory so your GPU can subsequently access. And a company like NVIDIA, they came up with different version of their GPU processor regarding the relationship between the GPU core and the cache and the memory. They came out different model. If you look at this, is interesting. Is keep changing, by the way. Minor changes mostly. And therefore, to understand this relationship is very important for the GPU programmer, because when your programming is not just get the work done, but you want to think about, well, how do I use this GPU architecture to save the memory copy, to save the time such that my performance will be faster. By the way, I also want to say the same issue between GPU and CPU. Memory sharing, for example, or copying. The same issue is actually happen to be the operating system memory management. They're dealing with the same thing. So therefore, I highly recommend, if you want to do a very well, not very, but relatively lower level in GPU programming. That means you want to write a program that have a high performance, and you want to be able to manage multiple GPU and memory at the same time. You need to eventually take a solid course in operating system kernel, which is typically operating system kernel should talk about what's the techniques that you can manage the memory on a multi-processor machine, multi-GPU machine, or even distributed processing. It's the same principle, but it happened at different level. Okay, so having said that, I want to come back to go over, probably for most of you, the first few GPU program. Okay, let me go to this hello, the easiest one. So the hello is nothing to do with memory. It's just to do with the computing activity being distributed. So so you can see that the way I define line 5 to 7, this is called a part of code is going to load on the GPU. It's going to execute there. Of course, this program is so simple. It's simple to a point, it doesn't make sense anymore. Number one, it doesn't have any action. It's just an empty function. And it doesn't take any argument, means that you don't need to copy any memory. Okay, so this is the simplest one, but I want to tell you that how you can actually call it. When you call this, you have to use, of course, the name of the function is called my kernel, but then you're going to use three smaller than and three greater than, and within here you have two arguments, which means that this is going to tell you that how you're going to execute this program, how many copy you're going to run it, and to also how many different kind of threads you want to run for this function. Okay, so this is, you have a two argument that you can actually control. So I want to show you a slightly complicated slightly complicated program, and which actually make it memory, and you can see that the difference between those two. So let's using adding. I want to do an add. Let me see, should I do this? Okay, this is add, that's good, that's good. So I have a program which will add a bunch of things. I want to add, you can see that I'm actually adding integer A and integer B, and then the result is going to be integer C. Okay, I'm actually going to get to my GPU to add, but the code over here is interesting. that this part you can see that A and B, the reason I say integer star A, integer star B, integer star C is because A, B, and C, they are vector. They are array. That means if you think about that, if I have a 512 GPU core, N is 512. If I have a 512 GPU core and I have an array of A, B, and C, and each of them have 512 elements. So potentially, I can just in parallel assign all 512 core to process the addition of each of the index of the array. So I can concurrently compute a 512 vector addition at one shot by using 512 vector. So that's actually very fast. But I want to, before I actually talk about the detail within the line number 9 to line number 12, I'm actually going to tell you the memory copy. Okay, so now let's look at the main program. You can see that what I want to do is I want to have the, okay, in order for me to do that, I have to have the memory about 512 element of an array for A and B and C. So there are 3 vector of 512 elements. And okay, remember in the C program, I have something called malloc. So malloc is allocating memory dynamically on the CPU or operating system memory space. But in CUDA, I have another function called CUDA malloc. So I need to allocate memory on the CUDA side. And also at the end of my program, I have to do CUDA free. So essentially, CUDA malloc and CUDA free, they're equivalent to malloc and free, except they're not allocating memory in your CPU access memory space. They're actually accessing from the GPU side. Okay, so that immediately there is a one difference. So you know that you have to do that to allocate on the GPU side. And the second thing is that you have to copy the memory. So here is the way you can copy. The CUDA also have its own main copy. So in the Unix command, you have a main copy. Typically, everything related to CUDA, if you remove the first 4 letter CUDA, then the remaining commands should be exactly has a corresponding system call or library function call within the traditional Unix C development. Okay, so you have a CUDA main copy, and main copy has is a little bit different because typically when you do memory copy, it takes about 2 or 3 arguments. If you do a main copy, let me actually see this one. If you do a main CPY, main copy. Okay, you can see that this is a main copy, copy memory area. This is a library function call. If the 3 is a memory library function call. If the 2 is a system call. Okay, if you will take operating system course, then you will learn the difference between library function call and system call. Okay, that's another important concept to learn. Okay, so you can see that memory copy, I have the destination, meaning that I'm copied into that, and then I have the source, and then I have the size. So now let's actually get back to this code. So this code is you're copying from A, which is the source, to the destination, which is the DA. So DA is essentially the pointer or the address or the vector or the array. By the way, in C, array and pointer and address, they're all equivalent. Okay, these 3 concepts are identical. So I basically copy from my CPU space to my CUDA space using CUDA main copy. And this is the size. This 3 is equivalent to the main copy of the first 3. And then in the CUDA, I actually have to do this, is I have to specify whether when I'm doing this, I'm actually copy from the host to the device or the device to host. So host is, in CUDA's terminology, host is your CPU. and device your GPU. So when you specify this, this is basically copy the A array with this size from your CPU memory to your GPU memory. Okay, so this is actually, if the amount of memory you're going to do the copy is pretty large, then this is going to be expensive. I mean, for example, if you copy a large language model, if you can compress the language model to be small enough to fit into the memory of a GPU, then essentially you will specify that size. And before you can use your GPU to run your large language model, that you have to copy over there. That could be very expensive. And that's why there is just for those of you interested in LLM, that's why in machine learning, in LLM, there is a one concept called model compression. So the idea of a model compression is I want to make it small enough such that I can fit one GPU memory. If your LLM is larger than one GPU memory, then you're in big trouble because you need to move there, part of it, and then move back, part of it. So you're going to do CUDA mem copy back and forth a lot, which will kill your performance. So it's not about how many GPU core you have, it's about how much memory you need to copy. So this one is CUDA memory copy. That's actually memory from host to device. So after you compute, this is the line is after I call this add n to 1, because I'm actually letting them to do 512 at the same time. And then I have another CUDA min copy, but this time you see is reversed. The first two arguments reverse, which is I'm actually copying from the CUDA space to the GPU space, CPU space, sorry, with the same size. And then you see the argument, it says that CUDA main copy device to host. Okay, so essentially, if you want to start writing your first GPU program, it's really only a few things you need to learn. The first thing you need to learn is global. And the second thing you need to learn is CUDA malloc and CUDA free. And the third thing you need to learn is CUDA main copy with this. And the rest of them is, okay, there are, of course, two more topics we need to cover is, okay, this is critical because over here, you're going to control the threads. You're going to control the parallelism using this two argument over here. That's a concurrency control using the three smaller than sign and three bigger than sign, which I actually don't like that. I mean, it's a kind of not so nice syntax. And the other thing is you have a block index and also you have a thread index. If you come over here, a more complicated example is over here is addition with a thread, which you can see that I'm actually using the thread index to help me to find the data. But the thread index, I'm only show you X, but this could be X, Y, and Z. And the other part about the CUDA memory you need to learn is about how do you do synchronization and how do you do share memory. If you're familiar with all this topic, you probably very, very well to go with your GPU programming. Okay, let's take a break and we'll come back.